What is three-dimensional graphing? A three-dimensional graph is the graph of a function of two variables, f of x and y, where f is set to all points x, y, z, so that z is equal to f of x and y. Finding the intercepts. To find the intercepts on a three-dimensional graph, your first step is to find the x-intercept. You do this by plugging 0 in for both y and z into the sample equation shown on the left. In a similar process, to find the y-intercept, you plug in 0 for x and z. Finally, to find the z-intercept, plug 0 in for x and y. And if you do this, you'll see something similar to the graph seen on the right. Imagine a stick poking through a piece of paper. The stick rips through the paper to create something similar to the picture on the right. Now, this stick represents the z-axis. The paper would represent the y and the x-axis. Now, with a height of 7, length of 4, width of 5, and total volume of 36, solve for the values of x, y, and z. Now, I'm going to slow down a bit for this part, as right now we're going to be solving the problem, so I want to give a little bit of the time for the people working on it. The first step is to find the x value. As previously discussed, replace y and z for 0. This finds us our x-intercept and our width of the paper. The value you should get for x is 7.2. The next step is to find the y value. This step is very similar to the previous one in that you're basically doing the same thing. To find the y-intercept, you want to replace x for 0 and replace z for 0. By doing this, it only leaves y with a value, and then you can divide. This finds us our y-intercept and our length in this scenario. The value you should get for y is 9. The last step of finding the intercepts is finding the z-intercept. Now, like said previously, this one is pretty much the exact same as finding the x and the y-intercepts. You're gonna replace x for 0 and y for 0, and then divide. This finds us the height of the pencil going through the paper. The value you should get for z is 5.14. Now, after you have all of the intercepts, the final step is to plot the points. Interestingly, the z-axis starts negative and in the top right corner, which is the opposite of how the x and y-axes are on a 2D plane. So instead of positive values in the first quadrant, like it is normally, you would find positives going near the third quadrant. However, in a 3D scenario, the graph looks like more of a spread and would look like something shown on the screen. As you can see, the x, y, and z intercepts all go through their values on their axes. Now, as said before, after these axes are put together and the intersects all co-align, it shows up as a plot on this graph, which would be our answer to this question. Again, as you can see, x equals 7.2, y equals 9, and z equals 5.4. And the graph, as discussed before, is on the right. I hope that you learned the general concept of 3D graphing. Take care.